Today we're going to talk about a guy named Johannes Kepler. He started out looking for God's perfect design in the stars, but his deep respect for data forced him to tear down 2,000 years of belief. It's really a story about a detective, a cosmic mystery, and a universe that just refused to be perfect.
And that right there is the big question, isn't it? For centuries, the absolute smartest people on the planet were convinced that the universe ran on these perfect, elegant, geometric rules. But what happens when the messy, inconvenient reality of the data tells a completely different story? All right, so let's set the stage. For nearly 2,000 years, think about that, from the ancient Greeks all the way to the Renaissance, pretty much everyone who was anyone agreed on one single fundamental idea about how the heavens worked. And, well, it was completely wrong. So, you had the old-school Ptolemaic model, with the Earth smack in the middle of everything. And then you had the revolutionary Copernican model, which put the sun at the center. Big change, right? But look closer. What's the one thing they both have in common? Perfect circles. Even a game changer like Copernicus just couldn't bring himself to let go of that ancient idea that planets had to move in perfect circles.
And here's the kicker. Because both of these models were built on that same shaky foundation, neither one could actually predict where the planets would be with any real accuracy. They were beautiful ideas, philosophically elegant, but they were wrong. The numbers just didn't add up.
And this is where our guy comes in, the young Johannes Kepler. He was an absolutely brilliant mathematician and also a very religious man. He was totally convinced that the universe was a reflection of God's perfect plan, and he figured he could uncover that plan using perfect geometry. So Kepler's first big idea, which he published back in 1596, was just stunningly beautiful. He came up with this model where the orbits of the 6 planets we knew about back then were perfectly separated by the 5 perfect geometric shapes, the Platonic solids. It was this gorgeous attempt to find a divine harmony in the cosmos.
What a beautiful idea, right? So elegant. There was just one tiny problem. It didn't work, not even close. When Kepler actually compared his perfect geometric model to the observed distances of the planets, they didn't match up. And that failure? It was maybe the most important moment of his life, because it taught him something huge. A beautiful theory isn't enough. You have to follow the data.
Okay, so his first brilliant theory is in ruins. What does he do? He knows he needs better information, so he seeks out the one man in the entire world who had the best, most accurate astronomical data ever collected. The legendary, and let's be honest, kind of cranky, Danish astronomer Tycho Brahe.
You can just hear the confidence in Kepler's own words. He saw Tycho as the guy with all the raw materials, the best data in the world. But Kepler saw himself as the architect, the one who could finally build the true model of the universe from it.
Now, Tycho was super secretive. This data was his life's work. He wasn't just going to hand it all over. So instead, he gives Kepler this one single, notoriously difficult task: figure out the orbit of Mars. This was the planet that had been giving astronomers headaches for centuries with its weird looping motion.
So Kepler gets to work. And after years of brutal calculations trying to cram Tycho's perfect data into a perfect circle, he finds a tiny error, an 8-minute of arc discrepancy. Now, to put that in perspective, that's a sliver of the sky about the width of a thick coin held at arm's length. Anyone else might have just fudged the numbers or blamed it on an error. But Kepler trusted Tycho's data more than he trusted 2,000 years of dogma.
And for Kepler, that tiny gap wasn't a mistake, it was a revolution. He realized that this little error was proof that the entire system, this whole idea of perfect circles, it had to be wrong. The data was practically screaming the truth at him.
And that realization, that decision to trust the data over everything else, is what led to his legendary breakthrough. He knew what he had to do. He had to break the circle.
So his first law, published in 1609, the law of ellipses, turns out planets don't move in perfect circles at all. They move in these slightly stretched out circles called ellipses, and the sun isn't at the center. It's at one of 2 focus points. And when he tried that shape, the data for Mars fit perfectly.
His second law got even deeper. It described how the planets moved on those elliptical paths. They actually speed up when they get closer to the sun, and they slow down when they're farther away. Now, this was huge because it suggested some kind of force from the sun was pushing and pulling the planets. He was moving past just geometry and into actual physics.
And then, About 10 years later, he found it, the master key, the law of harmonies. It's this one beautiful mathematical equation that connects how long it takes a planet to go around the sun with how far away it is. It was a single, universal rule that tied the entire solar system together.
So if you put it all together, it's just incredible. The law of ellipsis swapped a pretty philosophical idea for cold, hard, empirical reality. The law of equal areas pointed to a physical force coming from the sun, and the law of harmonies proved that the solar system wasn't just a collection of things, but a single, unified system.
But Kepler's story doesn't actually end with him. His work wasn't just an amazing achievement on its own. It was the absolutely essential foundation for the next giant leap in science, a leap made by some guy named Isaac Newton.
Think about it like this. Kepler's 3 laws gave us the what. They were the perfect description of what the planets were doing. He wrote the rulebook for the solar system, laying out the precise mathematical laws of their motion. But it was Isaac Newton, decades later, who picked up Kepler's rulebook and figured out the why. He discovered the underlying physical reason that explained everything Kepler had observed. And that reason, of course, was gravity.
And the connection here is it's mind-blowing. Kepler's third law, that p squared is proportional to a cubed thing, that was the exact mathematical clue Newton needed to figure out his famous inverse square law of gravity. It's like Kepler found the lock, and Newton came along and forged the key that fit it perfectly.
When you look at the whole story, Kepler's journey is really the story of science itself. He started as a mystic, hunting for divine geometry in the heavens, but his absolute refusal to ignore the evidence transformed him into a true data detective. He built the bridge that took us from the philosophical world of the ancients to the mathematical physics of today.
And that brings us all the way back to the beginning. But this time, the question is for you. Kepler had to ditch a beautiful 2,000-year-old belief in perfection, all because of a tiny piece of data that told him he was wrong. It just makes you wonder, what cherished ideas do we hold on to today that we might have to let go of if the evidence pointed us somewhere else?